again I am back with another set of my video on acids, bases and salts. And in the previous video I told you about various important salts and their common names, their chemical names, and what are their uses. Okay, so in today's video we will be talking about some important salts which are derived, or some important chemicals which are derived from common salt. Okay, NaCl. Right. So when we are talking about chemicals, the very first chemical that I am going to talk about is sodium hydroxide. Okay. Now it is something very important because this sodium hydroxide is used in textile industry. It is used in the manufacture of soap. Okay. Now and similarly, it is used in the descaling of these broilers and all that. Boilers, so to descaling. Sometimes the salts and everything just get accumulated in these boilers when the water evaporated reaches the salt. So that descaling of the boilers is also has to be done. So everything is done with the help of this NaOH or sodium hydroxide. Okay. Now let us see how sodium hydroxide is produced from common salt. So what we do is we prepare 20% NaCl solution. Okay, 20% means in 100 ml of water you are adding around 20 grams of NaCl. That is what 20% of NaCl solution is, and it is also called as brine. Okay, so the aqueous solution of NaCl is known as brine. So this 20% aqueous solution of NaCl, what we do is we pass electricity through this brine solution. So whenever electricity is passed through this brine solution, what is happening? It dissociates into sodium ions and chloride ions. Okay, right. Now, what happens at cathode? At cathode, the sodium ions, it takes the electron. Now, actually, what happens is that the chloride ions, they move towards the anode. Okay. Now, when they move towards the anode, they release the electrons because they have excess of electron. That's why they are negatively charged. Okay, so whenever they go to anode, they release those electrons and they become chlorine atoms, and then these chlorine atoms, they combine together to form chlorine gas. So chlorine gas keeps on evolving from the anode, right? And then these electrons, they are taken up by the sodium, and so the sodium ions, what they do? They go and they take the electrons from the cathode because cathode has extra electrons, and they become sodium atoms. Okay, sodium. Now sodium is very reactive metal. It's very reactive. So if you allow sodium to be there in water, it will explode. Right? It will explode. So we cannot have sodium remain in water in the way it is. So what we do is we alloy it with mercury. Okay, so the sodium is alloyed with mercury to form sodium amalgam. Now any alloy in which mercury is a metal is always known as an amalgam. Okay, so we basically form sodium amalgam. So the sodium amalgam is formed. Now that saves everything because it prevents everything from exploding. Now this sodium amalgam, actually it reacts with water. So you can see this is there. So this happens at cathode, this happens at anode, and this is what is happening now ultimately. So this sodium amalgam, it reacts with water to form sodium hydroxide and hydrogen. Okay, and hydrogen. Right? So if you look at this net reaction, so you can sum up everything and write it like this: NaCl plus water, this is the brine, we call it as brine. Okay, brine, it undergoes electrolysis, and what is formed? NaOH, then chlorine gas is released at anode and hydrogen is released. Okay, so when I say this is the product formed, and there are two byproducts which are formed, one is chlorine and one is hydrogen. Understood? So this is the net reaction. You can see this is the net reaction of this entire process. And what is this process known as? It is called chlor-alkali process. Why chlor-alkali process? Because chlor means chlorine. The chlorine is released, and alkali, of course, the sodium hydroxide is formed. Okay, so because of this, we call it as chlor-alkali process. Understood? So, then all the products that are released or that are produced in this particular reaction is very, very important. For example, when I talk about hydrogen, so hydrogen is basically used as a rocket fuel. Okay, then hydrogen is used for the manufacture of ammonia or for the manufacture of fertilizers. Okay, so this way hydrogen finds a very important role in all these things. Then we have chlorine. Chlorine, we all know that it is used as a bleaching agent. It is used in the manufacture of pesticides, or it is used in the manufacture of PVC. So for all these things, chlorine is important. And NaOH, of course, I told you about descaling of the boilers and manufacture of soap. Okay, so for all these things, NaOH is required. Okay, so you can just go through the various uses of these particular substances. Is it clear? So now everyone is clear the chlor-alkali process. What is chlor-alkali process? How do we manufacture sodium hydroxide from NaCl solution? So you can note it down. It's very simple. Okay, it's just by the electrolysis of NaCl. So you just have to write what happens at cathode, what happens at anode, and then sum up the entire reaction. Remember this sodium amalgam. This is very important. Okay, so you just can't write down sodium because sodium is very reactive and it could explode everything in water. So sodium amalgam is actually reacting with water to form sodium hydroxide, and hydrogen gas is released. Is it clear to everyone? Okay, so that was sodium hydroxide. So in my next video, I am going to come up with another chemical that is manufactured from NaCl. Right? So till then, take care.